welcome everybody. This is the Future of AI Software panel, and we are delighted to have a set of amazing experts with us here on engineering, software, and data science. And so we've got a group of folks. We'll start with Brian from NVIDIA. Chris, of course, needs no introduction, co-founder of Modular. Damien from Meta. And Sean. Great. Feel free to grab a seat. So we are really excited to have a conversation today about the future of AI software. But first, before we get started, I'd love to have each person share a little bit about their background so that we have some context about what we'll be discussing today. I'll kick it over. Actually, I'll start. My name's Dave Munichiello. I'm at Google Ventures. Google Ventures is entirely separate from Alphabet. We're a standalone venture fund with about $8 billion under management, investing in companies at the Series A and Series B, early stage companies that we're incredibly passionate about. We do a lot of work in AI, so we have a tremendous number of AI companies that we support. Those are both companies that are building for AI, companies like Modular that are building for developers, that are thinking about building the next generation of product on top of AI, and then companies that are building with AI. So applications that are incredibly exciting, that are transforming our world. And I'm fortunate to be here with you guys, so I'll kick it over to Brian next from NVIDIA, and we'll go down the line.
Great. My name is Brian Catanzaro, and I'm VP of Applied Deep Learning Research at NVIDIA. And my goal is to find new ways of making AI useful for NVIDIA's own work. I've been at NVIDIA for about 15 years, and I've had the fortune of helping NVIDIA become an AI company. Back in the day, I wrote cuDNN, which was NVIDIA's first library. And these days, my team is known for Megatron and for DLSS, and we continue to push NVIDIA's own models forward. So happy to be here today.
Very cool. I'm Chris. I think you know me probably.
Hi, I'm Damien Sereni. I'm an engineering director at Meta, and I support the PyTorch team within Meta. I've been at Meta for about 12 years now. Actually, relatively recent to the PyTorch space. I've been supporting PyTorch for about a year and a half. Prior to that, I spent the previous 10 years working on compilers within Meta. So
love developers, right?
Exactly. Yep. All about developers. Pass it to Sean.
Yeah. Hi, I'm Sean, also known as Swix. I spent most of my career in developer tools companies, AWS and 3 Unicorns, and most recently started writing about the rise of the AI engineer, which I consider a subset of the AI developer that Chris is building for. Had Chris on the podcast, which we loved, by far the longest podcast, and we had more to go. We just had to cut it for time, but really enjoyed our conversation and excited to be here.
So some of the exploration areas that we're going to talk about today include application advancements that are driving the enthusiasm for AI, and then the underlying complexity that's getting driven out of a lot of this infrastructure underneath AI. We'll talk about some infrastructure trends and development trends. We'll talk a little bit about open source and proprietary models, one of our favorite conversations, data centricity, model centricity, and then the future of AI beyond the transformer. So this is kind of like high level of what we're touching on. Just as a quick framing for the conversation, at GV, as venture capitalists, we're often thinking about the cycles of innovation that are happening and the different timelines of those cycles of innovation. So if you're the CEO of a Fortune 500 company that's thinking about AI, you might think about how AI might transform your company for the next 30 years. If you are a venture capitalist, you might be thinking about what the next 8 to 10 year cycle looks like. And if you're a hedge fund owner, you might be thinking about quarter to quarter returns or changes in your business. And each constituency thinks differently about those timelines. We're excited about two major parts of AI. So one is, computers and software learning in a way that feels more human, and computers and software interacting in a way that feels more human. Both of those things we think will create step function changes in the way that we all compute on a daily basis. And before all of these amazing applications come to the forefront, there will be a compression in some of the technology that's out there. And Brian, I wanted to start with you because we hear often from NVIDIA, we hear often from a lot of the chip players that the demand for compute is almost endless, that it will just go on forever as a result of AI. And I'm curious, just from your vantage point, you're seeing a lot of the demand for compute right now. How would you characterize that demand today? And when you think about the cycles, is this a 5-year phenomenon, or is this sort of a 20-year cycle that we're thinking about?
Yeah, well, I think with AI, we have found a way to turn computing power into intelligence. And so if you ask yourself, how much intelligence do we need in the world? The answer is a lot more. Do we know what the limit is on the amount of intelligence that we want to see in the world? I don't know what that limit is. And so that tells me that the limits that we're going to see on compute for AI are going to be connected with economic limits. They're going to be connected with, what's the ROI that people are getting for their investments in the infrastructure that's necessary to power AI. And given that a lot of these applications have the potential to be pretty useful and change the way that we do a lot of things as humans, I think that that means that there's going to be a lot of demand. And my efforts to sort of predict exactly how much compute we're going to need for AI, I've always been a little bit too conservative. And these days there's some truly astounding things that are being built to power AI. I did also want to say, though, that I think that there's the way that I do demand forecasting for my own team, I spend a lot of time actually doing demand forecasting for NVIDIA for our own AI efforts. And we end up needing to do kind of a combination of bottom-up project-based proposals as well as kind of trend forecasting. And I found that it's important to remember that many projects can't absorb infinite compute in an infinitely small amount of time. Like there's a ramp that happens just in terms of like people and their workflows and the data sets that they're working with and the problems that they're trying to solve. And so, although I do feel like the demand is basically infinite, I do think that the way it rolls out is constrained by economics, sort of by the ROI of artificial intelligence, and then also by the learning curve of the people that are doing the work.
Certainly feels like the demand for NVIDIA chips right now is nearly infinite. I mean, the world is lining up to buy more and constrained when it comes to supply. Chris, you previously supported CPUs, and you announced today support, GA product of GPUs, supporting GPUs. Can you tell us a little bit about how you think about the balance of sort of CPUs and GPUs going forward when we think about training, which is taking up the majority of compute today?
I think that the way I look at compute in general is it gets very specialized for different use cases. And so if you look at what is good for an LLM versus the chips that people were talking about 2 years ago before they really took off, you need way more memory bandwidth, for example. And there's a whole generation of chips that were designed to be SRAM centric that didn't have the ability to feed the chip, that then kind of were not as relevant to today's models. And so I actually feel very glad that we have hardware leaders that can see over the hill, because you have to make bets that are multiple years ahead and make investments and really understand the research side of where things are going. You have to understand and predict what will take off and then be able to adapt rapidly, right? And so from, fortunately, the software perspective, right, we can wait until the hardware's coming out and then we can see that and steer into that. But there it becomes much more about how do we get people to actually understand the hardware, how do we make the programming model work, how do we pull this in, and how do we catalyze and drive these new kinds of use cases. And so the thing I love is you talk about CPUs versus GPUs, right? These are both very good for different things, right? But there's also, if you look at a cell phone or something like that, you have this whole mix of heterogeneous compute and this very weird system, and nobody knows how to program this, right? And so to me, it's about unlocking this capability of all this exciting hardware out there. I don't personally know what the use cases are, and I know some of them, but I don't know all of them. But that's why I'm a tool maker. I'm not the applied product person. And so from my perspective, again, I feel fortunate that I can help catalyze innovation and things like this without exactly knowing where it goes. And seeing where it goes is part of the fun part.
Awesome. Damien, curious, from your Meta experience, PyTorch is obviously widely used, widely loved by researchers. What are some emerging trends that you're seeing in sort of high-level APIs and the future of PyTorch?
Sure. I mean, first, I'll kind of echo what Chris was just saying, because I mean, I think one of the trends that we're definitely seeing is, the range of hardware that we need to be programming for is just getting more and more diverse over time. Anything from, variety of GPUs, accelerators, which are definitely kind of exploding in diversity right now, and then kind of edge devices and kind of all the complexities that has. So I think one of the challenges that we're really excited about from a PyTorch perspective is kind of how do we make that manageable for the ML developer, right? I think when we're talking about one or two architectures, it's like fairly straightforward to have people adapt their models and deeply understand the hardware. That's really just not going to continue to scale to the variety of hardware that we have coming ahead. So that's one big trend that we're trying to get ahead of, and that's what gets really exciting, to Chris's point, as a tool maker, that we get to be this interface between the hardware and the modelers. I think another set of trends that I'd probably call out is anyone who hasn't been hiding under a rock, obviously the explosion in popularity of LLMs and foundational models is kind of changing a lot of how we think about things. And so there, I think there's a few sort of different implications that has. So one, maybe the more obvious one, right, is very, very large-scale distributed training for these huge models is becoming more and more important, and it's something that I think we're still behind where we should be in terms of meeting the capabilities of the hardware and the deployments out there for training these models. I think the second one, though, is training is one part of it. Inference cost is with LLMs is becoming kind of more and more important and a big, both in terms of latency and the actual hardware cost. So I think we're going to see a lot of innovation in the LLM inference space and kind of how we can optimize that. I guess the final one I'd call out is with the rise of these kind of big foundational models, there's kind of this increasing gap between, on the one hand, the amount of hardware that it takes to train one of these and to do pre-training there, which is kind of prohibitive for most people. But on the other hand, this gives rise to a whole much broader audience of people who are actually excited about doing fine-tuning and taking these foundational models and building really innovative applications on top of that. And typically with way fewer resources, constrained by number of GPUs, constrained by VRAM, and all that. So I think one of the things I'm really excited about is really kind of raising also lowering the bar to entry for people doing fine-tuning across these existing models.
Meta has been instrumental in the open sourcing of a lot of the foundation models. Curious to learn more about, how do you think about large proprietary models that are, large companies are spending hundreds of billions of dollars to train versus some of the open source models that are coming out? And how important are those open source models to attracting the developer that you've been talking about?
Well, I mean, I guess from Meta's perspective, right, we're pretty much all in on open sourcing models. So my answer is going to be pretty straightforward there. So I'm not going to take the credit for that, but no, but seriously, I feel like it's at the end of the day, there's always more developers out there and more researchers out there than what any one company can actually staff. And so we're always going to see a pace of innovation in an open community eventually catch up and overtake what I think any one player can do. And we've definitely seen this with Llama 2. When we open sourced this, it was less than 6 months ago, right? And we're already seeing sort of thousands and thousands of derivatives of Llama 2, really significant improvements on benchmarks that people have made, and just a ton of innovations that are happening on top of that. So I think it's also a way to close that gap between the computational resources required to train one of these models and kind of the rest of the research community where a lot of the innovation is going to happen. So yeah, I'm just personally very bullish on the strategy to open source, whether it's on the LLM side of Llama 2, PyTorch, obviously, long history as an open source project. And I think I don't know, the last like 5 years of PyTorch have really shown that the innovation that's happening out there is always going to outpace what we could do for sure.
There's definitely innovation happening everywhere right now, and having open source models is extremely important to fuel a lot of that innovation. Sean, you spend a ton of time thinking about developers in general and ML developers in particular, and you have talked to many different companies in this space. Who do you think the companies are that are creating these gravitational pulls for developers around the ecosystem?
The ones that
there's a name
organize their own conference in their first year of existence.
Who else? Who are the companies that you keep an eye on when it comes to where developers are headed?
I have a few responses, actually. First of all, Meta's models are not entirely open source. Let's mention that, right? Like it's commercially available. Really appreciate the license, but they're not fully open source. And I think a lot of people really appreciate the licensing available, but
by the way, I think open source is a misnomer, right? I mean, we have the
it's
open
evolving.
source foundation that tells us what open source means, and actually, like the way that we talk about models isn't congruent with like standard principles.
It needs to evolve, and they're not leading that charge just yet.
Well, it might evolve, but I mean, the other thing is that when companies spend tens or hundreds of millions of dollars of compute time to train a model, they're unlikely to put it out there with completely no restrictions at all.
Yeah.
For a variety of reasons, because again, AI has to be driven by return on investment, right? In some way.
Yeah, so it's a topic it's a source of concern for, honestly, the research community, because all this, all the data that going into the models and the learnings as you go through training is no longer published. That's just the fact. Even Mistral, the sort of kings of the challengers to the open source title, is also not publishing a lot of what they're doing. So how open is open, and how much is humanity being sort of held back by the closeting of this knowledge at big model labs. There are two major events, AI events this week in San Francisco. One's this one, and the other is the News Research Olama sort of big thing at ACCZ. And so I think like that's another community that is developing, which is sort of the decentralized, very open, like legitimately everything open, research community that's happening over there, that I would point to as a interesting community that's been happening online. As part of my work, I track every single AI Discord out there, and I do a summarizer. Consistently, by far, that community is just popping off as the one that's sharing the most techniques, exploring the most deranged ideas. Some of which are interesting, many are very deranged, but you'll find a lot more innovative stuff coming out of there, I think.
Chris, today you announced tight relationships with a few different companies. What made you prioritize those companies and those relationships? You could create relationships with anybody in the world.
Interesting question. It's a number of things. One is it's what our customers are asking for. I think that's the number one thing, but also personal relationships and eagerness to work with us, I think, is also another major factor. And so there's no one right answer. We want to work with many different people over time, but we're also a small team. And so we prioritize based on kind of where our customers are pulling us.
Yeah, I saw AWS, NVIDIA, Replit.
And there'll be more. We have a bunch of customers that are very excited about what we're doing. And I'm sure a
lot of people very excited
talking whenever it's right for them.
Totally.
So.
We have talked about open source quite a bit. There's a little bit of a debate, Brian, about open source in general.
We're really disagreeing.
We're not disagreeing.
I don't think we're disagreeing too much. I love open access models. I just feel like, given how much work we've spent as a community defining open source terms, and like, for example, there's a set of open source licenses, like the Apache 2 license, like when we release the weights for these models, I feel like we're not using those open source approved licenses. I always feel like using the word open source for that isn't quite right. I feel like there should be some other word like open access or like unrestricted weights or something
There's a hierarchy of openness, and it goes from like data to model to weights. You can kind of zip up and down in terms of the openness or closeness of these.
Yeah. Curious, for this group, what do you think could be done to encourage developers and encourage large companies to contribute more to open source and to sort of spur innovation in open source?
I have to, Damien said he didn't want to take credit, but I think Meta does deserve a lot of credit. I've been working at NVIDIA to try to get permission to release the weights of foundation models that we've been training for the past 5 years. And I couldn't do it because there was a lot of people worried that these models would destroy humanity, right? I mean, it sounds funny to say it, but actually, like, that idea surfaced when GPT-2 was published, right? Which was in, I believe it was in 2019. So, so it's been 4 years now since, this idea that these models are so powerful that they might, like, destroy civilization has been percolating around. And because companies are naturally conservative, if somebody says, well, maybe this is dangerous, then, it took some courage, I think, for Meta to release the Llama family of models, Llama 1 and 2. And I think that they've done a tremendous amount of work to legitimize open access models and show the community, first of all, this isn't going to destroy civilization, it's going to make it better. And second, the amount of innovation that we find when people all over the world can experiment, on their own with this technology, it's really quite extraordinary. So I feel like that's been the most effective thing to get people more engaged is sort of just do it,
Yeah, and maybe I'll add, I think one of the insights that I think was really important to getting to, I'll say open access, not open source, so we don't.
I promise I won't pick on that anymore. I just think it's important.
No, it's totally fair. I think one of the insights there was, safety has always been a big concern with this, right? And there's a lot of people out there who actually are very concerned about open access models and kind of potential for misuse and so on. I think our belief is, at the end of the day, we'll actually end up with better safety by, being more open and having it out in the community so that way more people can, do red teaming and try and understand, hey, what are the flaws in the model, finding them and then helping that get fixed. So I think one of the big sort of alignments that led up to Llama being open was that sort of realization that it's actually better for the overall safety of the model for us to just be more transparent about it.
Yeah.
We spend a lot of time and energy thinking about training models, but of course, after training models is the inference and all of the compute that comes along with inference. And so, curious for this group, do we think that inference will continue to be sort of centralized within data centers, be pushed all the way to the edge, and what are some of the use cases that we see popping up as a result of highly performant inference being able to be done all the way at the edge, the phone?
I think there's a natural progression, right? Things start in research, and this is something I've seen in many different places before. The training costs are astronomical. You're trying to figure out the right thing. You're trying many different experiments. You're trying to fiddling around with all the parameters and model architectures and all that stuff, and then you find a killer app, right? And then there's something that's really interesting, and suddenly the march to get this into production starts. That march is very difficult. It leads you through many different alleyways and often back and cycling through a new training loop because you figure out you can't deploy the thing for whatever reason. And so today people are largely on cloud because that's where we have tools and that's where people can be successful. But I think there's a huge opportunity for AI on the edge as well. It's just that, we have supercomputers in our pocket, right? And the tools aren't quite as good. People don't understand it. There isn't this awareness of deployment when training the model. And so I hope we can see more AI everywhere, personally. I'm a maximalist. But I think there's a lot of obstacles and there's a lot of things in the way for that to happen pervasively.
What kind of obstacles are in the way today?
You won't be surprised. Tools, I think, are a big issue. Programming models, fragmentation, all the hardware makers building weird different phones that don't collaborate. And some dominant providers of these phones are not super collaborative with other people always. And so there are many challenges
that he may or may not have worked for.
You've lived these problems in the past, yeah.
I've read about them on the internet.
I have so one of our earliest hits in the podcast was with Jonathan Franco of Mosaic, now Databricks, and he had these two factoids or data points which I thought was really interesting. The first one was Google's budget for inference versus training was a ratio of sort of 2 to 3. Two for training, 3 for inference. Meaning, you just look at the most mature AI company out there. They're doing a fair amount of training still. because obviously Mosaic is very interested in having people trade stuff. So obviously they're very keen on reminding people that trading is not a one-time thing. So like on a long scale, I think that makes sense. And then just regarding the sort of AI at the edge thing, we have that today. It's Cloudflare. They're very proud of the fact that they're putting a bunch of people, they're shipping a bunch of people to like all their points of presence with GPUs in their suitcases, like loading up their points of presence with GPUs. But they are very underpowered. Like the best models they can run are like the 3 to maybe 7B models, extremely quantized. Jonathan kind of calls this effectively like the semiconductor model, right? There's a leading edge, and then there's the trailing edge of like, there's like people doing a 3 nanometer version, and then there's people doing like 28 nanometers. AI at the edge is going to be the trailing edge in terms of hardware, right? Like the stuff you run on your phones and at the edge.
Okay, I just want to back that up a little bit. So first of all, I love AI inference at the edge, and I think we're going to have some amazing applications that are running locally. But memory capacity is a huge problem because it's not scaling very fast, right? So if you think about how much memory was in your laptop 5 years ago versus today, it really hasn't 10x'd the amount of memory in the past 5 years. Yeah. So when we're thinking about some of the models of the future, and there are models being built that are just absolutely gargantuan. Just where are you going to put it on the edge? So I think there's going to continue to be a lot of really important models that can only be deployed in the cloud because they're far too big to fit on any edge device. And then, of course, there's going to be a lot of work to distill them and compress them and so forth. But my belief is that there's going to continue to be sort of the world's premier AI is probably going to be deployed in the cloud. Meanwhile, we're going to find enormous amounts of value by having local edge deployment as well. So I think they'll coexist.
So the transformer architecture has sort of led us to where we are today. It's a thing that we're spending a lot of time and energy thinking about, particularly with its impact on Gen AI. But inevitably, there will be something that comes along after the transformer architecture. Curious to the extent that people are willing to share, just where do you think this goes beyond the transformer? Damien, do you mind if I kick it over to you?
Sure. It's I feel like that particular crystal ball gazing is extremely difficult. But like depending on who you talk to, like you'll get half the answers will be like, "Yep, transformers are going to be it," and we're done forever. And personally, that's not a bet I would particularly want to take. So I don't think I have a good answer for where this actually goes. I guess I'll like reframe it a little bit in terms of, I think what really matters, at least from my perspective as a tool builder and a framework builder, is we actually don't know where this is going to go. Yeah. And the thing that we're trying to optimize for is really just like making it easy to innovate and sort of iterate, right? And I think the research community has surprised us over and over again. And the best thing we can do is make it easy. They'll get out of their way and make it easy for them to like figure out what that next generation is going to be. I don't know if someone else here has a view of what it's going to look like. I don't think I do, but I know that our job is to sort of enable that and make it easy for them to come up with it.
I mean, I will plus one you. I totally agree. There's discussion about FFT-based hyena networks and things like this. There's a lot of potential could be things. It's hard to know, and so I totally agree. One thing I think is also interesting is that the game's not over yet for everything else. Like big recommenders are still using DLRM, and there's a lot of other architectures. RNNs are coming back in certain categories, and there's a lot of innovation that's happening. And transformers are getting all the attention, and I think rightfully so. They should get a lot of attention, but just because you're the 60% doesn't mean the other 40% is tiny. In fact, AI is so big that even ResNet 50 and like these ancient architectures that are still relevant are still being used in production by tons of enterprises. So,
yeah, I wanted to highlight the importance of like the computational substrate for this question, as you'd expect, since I work at NVIDIA. But one of the things that's so fantastic about transformers is that there's a cycle that happens as we learn how to use them and as we get our data sets bigger, that because this particular kind of neural network is so scalable, it can drive the process of creating hardware as well as software. And then that creates kind of a continuous investment that it kind of builds upon itself, right? And this is kind of the classic innovation curve that we like to see in technologies. And I think any sort of neural network architecture that wants to replace the transformer needs to also have that characteristic. It needs to be extremely scalable. When we're training transformer models on very large systems with thousands and tens of thousands of GPUs, and we're able to sustain, let's say 50% MFU at 10,000 GPU scale, that's kind of incredible, actually. Like in the history of high performance computing, I'm not sure if there's ever been an algorithm that was this scalable. And I think that's one of the reasons why it's so successful. And so one sort of way to think about potential challenges to the transformer is to ask yourself, how do they fit to hardware? Are we able to figure out how to train these things and deploy them efficiently? And if they are, like, again, with the transformer, it was able to spur kind of continuous cycles of improvement on all fronts. So you have the hardware people doing hardware and the software people doing software and the AI people working on data sets and AI. And everybody was able to make progress at the same time, which then led to this kind of dominance that we're talking about.
Well, I think there's another challenge there, though, because, again, NVIDIA's not doing this, but I talked to other hardware folks that are building, for example, an LLM-only chip, right, where they're going to hard code everything, keep all state and RAM. It's going to be super fast at doing the one thing, but then model architecture changes and you get broken, right? And so I think there's this tension that is really interesting to see of generality versus specialization.
Yeah.
And how do we keep programmability in the mix? And so
that's the soul of accelerated computing, right? Is to try to figure out, like, how much generality do we need?
Can you afford?
How much specialization do we need? It's I think working at NVIDIA is one of the scariest things that I see every day is how we navigate that, right? Because if we do it wrong, if you work in this field, if you work in the field of accelerated computing and you make the wrong decision, you build the wrong thing, it could take years to escape from that. And so so that's kind of the trick of building systems for AI, is that you do have to think about these trade-offs.
We're seeing so many tech companies develop their own specialized compute. Meta recently has announced their own AI accelerator, and you see that across the board. Multiple tech companies doing the same.
I think the TPU is a decade old now.
How do you think about companies having their own accelerator? Is that problematic for NVIDIA, or do you think in the future companies have their own accelerator and enormous amounts of GPUs?
NVIDIA is a lover, not a hater. We come here, we love technology. So when people make awesome technology, we love that. Like the stuff that we build, of course, we hope that it's very competitive and we hope that people love using it and we hope that people find it valuable. But at the end of the day, I think we're all in this together to push technology forward. And, we're going to try to do that the way we know how, but we're certainly not upset when other people have different ideas. That doesn't mean we're not going to compete vigorously. We love everyone, but we also compete vigorously. So we're going to try to do our best. And like I said, the TPU is now a decade old, approximately, more or less. And I think it's been a really successful project in a lot of ways. And Google and NVIDIA are great friends. Where we are always working together, and we continue to make sure that whatever technology that we put from NVIDIA and GCP is as awesome as possible, and we're really happy to work with them.
And GV is entirely separate from Google, just to make sure that you're aware of that. But we do have a lot of investments in chip semi companies that are specializing, and of course Meta is developing its own chip. And curious, does the move towards specialized compute make it more important that there is a layer that provides choice?
I mean, certainly that's how we're seeing it, right? Our own chip is only just a small part of it. I think, from a PyTorch perspective, certainly like the way we like to see it is, we're lovers, not haters. We want to be we want to enable like every hardware platform out there, and some of them are going to be general purpose, and some of them are going to be much more specialized. The real challenge is, I think I mentioned this earlier, like it still requires way too much knowledge from the developer about the underlying hardware platform, right? And I feel like, looking at it with my sort of compiler hat on, we're still at the very beginning of like, how do we actually create, good abstraction layers? They're not going to be perfect, but at least that let most people not have to worry about the underlying hardware. And I think that's going to get increasingly challenging as we see kind of these very specialized hardware platforms. But yeah, I think from a framework perspective, it's really exciting because I think it's very challenging for us. But that's actually where we can add the most value and really like kind of enable this diversity of hardware that we're seeing. And that kind of includes the edge stuff that we were talking about before, right? Like I think that's where we see not just like fairly esoteric hardware, but like really, really tight resource constraints. And I think we're also just at the beginning of that.
Totally agree. So it sounds like we are in a world where we see almost an endless appetite for compute over time, a pie that's growing tremendously, an explosion of chip providers, an explosion of sort of hardware approaches, an explosion of complexity for developers. And if only there was something that could come along and make all of this, abstract away some of the complexity. Chris, do you know of anything that exists in that space?
I mean, some of us are trying hard. I mean, I think actually a lot of people in this room are trying hard to solve different parts of this problem together, right? So to me, I mean, I'd totally plus one Damien here. I would add plus one and add to it. It's all about getting people to work together, right? So if you're asking obliquely, like why Modular doing this thing, right? It's all about saying there are specialists that know the hardware inside and out. They know why it was designed the way, they know the maximum way to do this thing, the right way to hold it, right? There are people that then say, okay, I can figure out the abstraction layer. I can figure out the programming model. I can find the mental model for people to think about how to think about a category of chips. There are people at the application layer that then are saying, oh, well, I know now the best thing for autonomous driving or for self-checkout or for whatever it is that they're building at the application layer, right? And then what the magic that I think comes together is when you get people that can now escape their layer, right? They can innovate one layer up or down, and they can actually work together. And when you realize that solving and building products requires you to like actually cross the stack, you shouldn't have to relearn everything, or you shouldn't have to have a team that has the specialists at every single layer of the stack just to get something basic done, right? And so this, to me, it's a vote on developers and creativity and like problem solving, and it's that eliminating complexity part of this so that we can get the full utilization out of the hardware and we can make the flops go burr, but we can do so without the people at the top having to know about it unless they want to, right? And that unless they want to, I think is a big piece.
Yeah, something that Chris said to us when we were having our conversation is like, at some point, some researcher is going to want to try some new technique, and they should not have to learn a whole different language or switch to a different part of the stack to do that. And it gives me, like, when you ask this question about what comes after the transformer, it reminds me of this sort of Cold War type quote. Like, I don't know what World War III will be fought with, but I know World War IV will be fought with sticks and stones. I don't know what comes after the transformers, but it will probably be coded in something like Modular and Mojo, because it's so general. It's a language that is designed to be so expressive. And I like that insight that you had way before anyone else. Or stumble into.
Well, less important. But I mean, Dave, like there's another question to ask. Like, what if all of software worked the way that AI software did? Right? I mean, AI is new because it's accelerated, and there's new categories of new kinds of problems, new applications, and stuff like this. But software development for years now has been building layers of abstractions and developers working together, some open source, some closed, whatever. And so AI should be a reflection of the rest of the software industry. Right? And the software industry has been pulled together by standards, by collaboration, by partnerships, by new technologies, by people pushing the boundaries and new invention, right? And so AI is that, but it's all happened in like 5 years, right? And so what's happening is we get so much new stuff, right? It's hard to fit in your head. It's hard to keep track of the new model of the day, the new announcement, like that kind of stuff. And so this is where, my hope is that we can help break down some of those boundaries that, again, make it accidentally complicated and allow people to focus on the problems of the day and do these kinds of things.
Yeah, one interesting thing also just has to do with the nature of accelerated applications. Like, what does it feel to write applications where the value depends critically on speed? And I would say that the vast majority of the software development ecosystem has not been doing that for the past, I don't know, 40 years, right? What is that aphorism that what Moore's law giveth, Bill's law taketh away, you know?
Gates's law.
Gates's law taketh away. You know, the sort of idea that your software is running slower as a function of time because of the way it's written with all these abstractions and the things we're asking it to do, it just kind of piles up. And you know, so I think that there's been a lot of software that's been developed that way. One kind of alternative universe of software development, which is near and dear to NVIDIA's heart, is games and game engines, right? Because it turns out that the process of building a virtual world is also an accelerated computing process, right? And the value of the work that you do to write software for virtual worlds also depends critically on the speed, you know, because it changes what you can see, it changes how you interact with it, and you know, virtual worlds also have this property that the more compute you put in, the better the result. And so I think one of the interesting questions is sort of the links between like the game development ecosystem and the AI development ecosystem, because I think game development has been a place where accelerated computing has been mattering for a long time, whereas most software, you know, it's been the opposite of accelerated computing. And I think because we have this link between, you know, the speed of the system that you're using to deploy AI and the intelligence that you get from it, I think that link is going to stay there forever. I don't think that's ever going away. And so we need new kinds of software development that are for AI, but are able to preserve the speed benefits of the systems that we're building. And I think you know, some things are going to start to look more like game engines, like in the way that, you know, the process goes around to invent and deploy these systems. I think they're going to feel a little bit less like traditional software, and I'm always looking for links to the place where accelerated computing started.
Well, so I mean your point is really amazing, and to just double down on that, so you have GPUs for graphics in the game engine, for the physics, for the AI part of the game planning, all these different things, and so you have all these different subsystems all using the accelerator, right? And to me, I look at this and I say, okay, well, this accelerated compute paradigm that I think y'all have launched and have driven forward to great success really gets integrated with the host compute.
Absolutely.
Right, and so to me, that's where really AI is amazing, and there's hard to complain about the progress so far, but it's really about breaking down these barriers so that we can enable new kinds of acceleration, new kinds of use cases, and things like this. And to me, that's super exciting. And so, you know, again, these resonant 50 class models and things like this of yesterday, they're going to fall away. And I think that what we'll see AI become much more like a programming paradigm, where you have certain problems to solve, and AI is the best way to solve it. Piles of for loops are also cool. They're really useful for certain things, and I don't think that will go away, right? But it's about using the right tool for the job, and that's what I'd love to see, is like this integrates into all software in deep levels, and it's not just the chat bot, right, where it is just AI with a web wrapper, right? But it's like deeply integrated into so many of our applications on a level that we can't even imagine right now.
So I want to make sure that if anybody in the audience has questions, there should be somebody with a microphone who could share it with you if you have a question. But before we get to those questions, just wanted to take it one step further towards the sort of transformer approach, which is, you know, if we continue to add massive amounts of compute and massive amounts of data, where does this lead us? Where do you guys think that we're headed from here? And, you know, is it more exceptional experiences with computers? Is it, you know, do we get to a place where computing starts to feel even more human over time?
Yeah, I mean, I think AI is going to deliver new kinds of problem-solving tools and experiences that we can't even imagine. You know, it's like a new form of media. Like, you know, we're at the dawn of the movies, or the dawn of, you know, photos, or the dawn of the printing press. You know, like it's hard. You know, when Gutenberg printed his first book, he printed the Bible because that was the only book that people cared about. But like the changes that the printing press brought about on society were enormous, and a lot of the things that were built upon that were just completely unimaginable to Gutenberg back in the day. So I love a lot of applications of AI that are very practical and useful today for the problems that we have today, like for God's sake, can somebody please give me a scheduling bot so that I can stop having to manage my own schedule? That would be amazing, right? And it will happen, right? So there's some things that are like, we can see there's like a trail of, that's going to get us there. But then I think a lot of the things that we're going to see are things that we just can't imagine, you know, in the same way that my grandfather would not have been able to imagine that I get to spend my life working on artificial intelligence. You know, he was building oil refineries, right? That's what he did. And when he was building oil refineries, he had no idea that artificial intelligence was going to change the world. I don't know what my grandchildren are going to be working on. I think it's going to be completely different. But one thing that I do think is really important is that in a world with infinite content, you know, generative AI is making content of all stripes and shapes. And, you know, the thing that becomes most valuable is human attention, you know, and we're already there in a lot of places, right? Like there's way more things on Facebook to read than you could ever read, right? So Facebook's algorithm has to filter it because you can't possibly read all the things that your friends are writing, and you can't possibly watch every YouTube video, right? And so we're already at this place where like human attention is the most valuable way that we express our values. And I think that's going to be true in the world of generative AI experiences as well.
I'll throw in case you guys are buying time. I have some data points I've been collecting. It's funny that you talk about demand forecasting in NVIDIA. I wonder how far ahead you do it. Have you tried like going out to like 2030?
I have not. No, I'm just trying to get through 2023, and it's been a year. Let me tell you.
So here's some data points. Between generations 2, 3, and 4, GPT has grown by 2 orders of magnitude each time. And there is a rough roadmap. It seems like just based on public conversations from Sam and the other top leadership at OpenAI, there's a plan to GPT 10. And so that's 12 more orders of magnitude that we have today. That's about 10E. So GPT-4 is 10E25 flops. You can add 12 to that, 10E37. And that's an interesting concept. But you can sort of relate that with another guest that we had, George Hotz, who equates a human sort of unit of compute to 20 petaflops. And it sort of works out that GPT-4 took 100 years of human compute to train, the equivalent of 100 years, meaning it's one lifetime. If you assume a person lives 100 years. So if you project that out 12 more orders of magnitude, GPT-9 will have all the intelligence of every human alive, and GPT-10 will have all the intelligence of every human ever. And they're projecting that roughly by the end of the decade. What will it look like when we have that amount of intelligence? So you contrast that's the amount of potential, you know, obviously linearly projecting, like we run into natural physical limits somewhere. What would it, at the same time, like humanity is slowing down in our growth. I actually, for fun, just pulled out like demographic charts. Like demographics is destiny. We know what world population is going to be 30, 40, 50 years from now. We are at currently 77% of concurrent human intelligence right now. That there will ever be, assuming like we don't change our birth rate radically somehow. So meaning humans cap out, and then AI does this, and I feel like we should plan for that. I don't know how, but those are the data points I've been collecting because this is a very sincere interest of mine. Beyond the day-to-day, month-to-month, year-to-year cycles, these are the 10 to 100-year cycles that we're participating in, all of us.
Damien, you must see the impact of...
Actually, I like it. Sean, how much per token do you think GPT-5 or 6 will cost?
Oh God, it depends on the architecture, right? So like, yeah. I mean, what do you mean? What do you think?
If it's
I think per token is
token.
going to be the wrong way of thinking about it because, like, you know, some tokens are a lot more interesting than others. So I would imagine that sparsity.
I mean, I'm a fan of the emoji tokens personally.
And you know what? They really stand out on a slide.
They really do.
You know? But I think this idea of like, you know, right now, like the LLMs that we deploy, they're basically constant amount of compute per token, which is it's kind of a dense way of thinking about the world. I think it's going to be, we're going to have to deploy a lot of sparsity.
Yeah. Is sparse, okay, just to spell it out for people, is sparsity the same thing as more inference time? Like more test time search?
I think that some tokens should be a million times more difficult to produce than others, right?
Okay.
And when you think about it yourself, right? Like when you sit down to take a test, and you're writing out the answer, some of the things you're writing is not actually there's not actually a lot of thought that goes into it. Whereas other things, like you could spend days just trying to figure out one word to put in there or one character.
Nobel Prizes.
Sure, yeah, or like, in my own academic output, like some of the tokens that I've produced in my life have taken so many more years of blood, sweat, and tears than others, and that's just how it is, right? So I think that we're not going to get to GPT-5 or 6 kinds of levels of capability with architectures that require every token to be about the same amount of work. It just won't scale that way.
So I strongly agree with that. It's very reasonable that GPT-5 will be charged not just on per token basis, on a per amount of time spent.
Yeah, it's going to be. We're going to be seeing it. We're going to. If you ask it a harder question, you're going to pay more for the answer.
Yeah.
So can I ask Sean an easy question?
Sure.
When does the AGI get here?
Oh, God. It's always 30 years from now, which is actually not unironically, this is a thing that the sort of safety community has studied, which is it's always 30 years from now. So I don't know, and I don't really care. It's not like who cares if you're off plus minus by 30 years? Like we're still in it, and we still have to figure out what to do with it.
So we're at a place in the world where we're starting to see AI make people's jobs more effective, and eventually, we will find new jobs that AI can do that humans couldn't do in the past. And I think one inflection point that could be very interesting is when AI starts to discover new science, when new physics is discovered by AI. It may not qualify as AGI fully, but that would be an exciting milestone for humanity, for us to start having the work of some of the most brilliant people who are up here on this stage and out in the audience start to lead to humanity becoming smarter about the world around us with fewer humans inputting into that experience. That's something that we spend a lot of time thinking.
Can I just respond to that a little bit? So I think we're already there in some senses, in the sense that I think many of us working in this field feel very constrained by our ability to train and deploy AI. And, as a manager of a team, like if you asked me what's the gradient of like adding more people to the team, like adding more dollars to the team in humans or adding more dollars to the team in computers, I feel like I'm underinvested in computers. I think I have an awesome group of people. I'm so proud of them, and I want
You're very fortunate.
I want them to, be even more productive. But I feel so constrained by compute, and I'm spending, this may make you laugh a little bit, but it's the cobbler's child problem, right? Working at NVIDIA, every GPU that I get to keep for my work is a GPU that doesn't get sold to someone else, and so, the cobbler's children have no shoes, kind of a problem. But I think that problem isn't unique to me, right? Like I think there's a lot of places that are already at the point where they could really, really benefit from a lot more compute. And so it's not the same as like AGI inventing new science, but it is starting to feel like, like when I just look at how I spend my time as a manager, I'm spending more time managing my computers than the people in my team. And part of that's because I have an awesome team and they don't need a ton of management, but also it's just, I can see that as we add more compute to the work, the productivity of my team is increasing. And so that's the place where I'm spending more of my effort.
Feels like an awesome place to kick it over to Chris to wrap here. It's been a great discussion with you guys. And Chris, we are at a place where you're ready to introduce the next thing.
Yeah, well, thank you all for coming. I hope this was interesting. Thank you all to the guests. This was amazing. Thank you, Dave, for keeping us on track.